This is Baalbek in the Lebanon. Each of these 3 blocks weighs 900 tons.
Like, what is the weight of that? What's the overall weight?
That's 1.7 million pounds.
In Baalbek, Lebanon, there's a single stone block weighing 1,500 tons, so heavy that even the world's most powerful cranes can only lift a fifth of it. Furthermore, Baalbek boasts 3 blocks weighing approximately 900 tons. Yet some ancient civilization moved, lifted, and set them at a height of approximately 23 feet with millimeter-level precision. This makes this site one of the world's greatest engineering mysteries. The heaviest stone humans have moved with machinery in modern times weighs approximately 340 tons. This comparison explains Baalbek's difficulty. The blocks there are 4 times heavier than modern limits. Even the heavy lift crane at NASA's Vehicle Assembly Building couldn't lift these blocks. And yet these stones sit in place with perfect alignment. The most puzzling thing is the Roman silence. The Romans documented every construction, every engineering achievement in detail. Aqueducts, roads, temples, everything is recorded. But in the case of these massive stones, not a single mention. This silence in history raises the biggest question. Were these stones already there, long before the Romans arrived? Some archaeological studies suggest that these 3 large blocks, called Trilithons, are even older than the Roman period. This deepens the mystery of who cut, lifted, and perfectly placed such massive stones. In this video, we will seek answers to this very question. Who built the foundation of Baalbek, and how was such impossible engineering achieved? Before we start the video, like, share, comment, and subscribe, because the facts that follow will change your entire thinking. Located in the heart of Lebanon, the Bekaa Valley is a long, fertile, and incredibly ancient valley that has been considered one of the most important places in the Middle East for thousands of years. This valley forms a natural gateway between Lebanon and Syria, making it home to every major civilization. Everything from the climate to the terrain made this place home to people seeking a safe and central location for trade, agriculture, and religious activities. Baalbek, located high in the Bekaa Valley, commands control of the entire surrounding valley. This is why, in ancient times, it was not just a city, but a strategic strongpoint. Ancient trade routes both north and south passed through here, connecting major civilizations like Rome, Egypt, Mesopotamia, and Anatolia. These routes transported people, ideas, and goods from one civilization to another, making Baalbek a cultural and political center. History reveals that this place's importance wasn't limited to military or trade. Ancient civilizations considered Baalbek a powerful religious site. The massive stone platforms, temples, and structures built here indicate that Baalbek was not just a city, but a place where people displayed their greatest religious and cultural power. Therefore, the temples and structures here were not simply sized, but rather enormous, to reflect the power, identity, and engineering capability of their time. Over time, the valley was ruled by Phoenicians, Assyrians, Greeks, Romans, and Islamic rulers. Each civilization left its mark on Baalbek, but one thing remained constant. The site always remained under the control of a major power because its location was crucial to the security and control of any empire. Surrounded by mountains, the region served as a natural fortress, and the fertile land also made it economically strong. This is precisely why Baalbek's historical weight is so enormous. It is a place where civilizations not only passed through, but also stopped, settled, and left their mark. Its location has always made it a center of geopolitical, cultural, and religious power. The stone of the pregnant woman in Baalbek, Lebanon, is considered the heaviest carved stone in the world. Its estimated weight is between 1,000 and 1,500 tons, far beyond the comprehension of modern engineering. The stone was carved within the quarry, but due to its size and heaviness, transporting it from the quarry to the temple platform remains a major mystery. The stone is so massive that it is estimated to be approximately 70 feet long and 14 feet high. How such a massive stone was cut in a single piece remains a major puzzle for every researcher. The precision of this block is equally astonishing. Tool marks are visible on the surface, but these marks do not match those of ordinary tools of the time. The straightness of the cutting and the smoothness of the edges clearly indicate that it was created by a highly organized, skilled workforce. Most importantly, a larger carved stone has never been found at any ancient site in the world. No larger monolith has been found in Rome, Egypt, or any other ancient site. Therefore, it is considered an unmatched example of ancient engineering. The real puzzle of the stone of the pregnant woman is its transportation. The distance from the quarry to the temple site is only a few hundred meters, but moving such a weight even slightly is a challenge, even for modern machines. According to modern engineering, when we consider the factors of friction, terrain, and weight, all three together, lifting or sliding this stone seems nearly impossible. For this reason, archaeologists believe that the stone may never have been moved or that its entire plan remained unfinished. But it is also clear that its carvers were fully aware of its massive scale and still carved it in a single piece. Now let's talk about the three legendary stones called the Trilithon blocks. These are considered Baalbek's most iconic and most intricately engineered stones. Each stone weighs approximately 800 to 900 tons, and all three are fitted in a perfectly straight line on an elevated platform. The most astonishing thing is that they were placed not on the ground, but at a height of approximately 23 feet, with millimeter-level precision. When these blocks were aligned, any small error would have jeopardized the stability of the structure, so this accuracy is almost unheard of in the ancient world. The joint lines between these blocks are so clean and tight that even today a normal thin blade cannot penetrate them. This shows that both stone cutting and stone placement were carried out with extreme skill and precise planning. Even with today's engineering, placing a 900-ton stone at this height is a very complex process. Even with the help of modern cranes, counterweight systems, and hydraulic tools, such a task requires days of planning. But at Baalbek, this feat was accomplished at a time when even the availability of wheels, cranes, and advanced lifting tools was limited. Another major puzzle is the placement of the Trilithon blocks, balancing and leveling. The smaller stones beneath these blocks are aligned in perfect geometry. This means that the foundation was flawlessly leveled first, and then these heavy stones were lifted or slid into precise position. Analysis of the contact points between the foundation and the blocks proves that the entire platform must have been measured, leveled, and tested multiple times before these stones were placed. Archaeologists believe that the Trilithon blocks were built for a purpose that required extreme strength and stability. Perhaps it was a massive platform on which later civilizations built their temple structures. But the real question is whether this platform was built by Roman engineers or whether it existed before the Roman arrival. Since there is no mention of the Trilithon in Roman records, it is likely that this construction is much older. Taking the stone of the pregnant woman and the Trilithon blocks together clearly makes Baalbek an ancient site where engineering still challenges the world. Whether it was transport, lifting, or precision cutting, these stones set standards that even modern machines find difficult to replicate. That's why Baalbek is still considered one of the world's most mysterious and advanced ancient engineering sites. In today's modern engineering world, we can erect the heaviest structures, build skyscrapers, and construct bridges. But when it comes to Baalbek's 1,500-ton stones, even modern machines fall short. Today's most powerful crawler cranes, like the Liebherr LR 13,000, can lift approximately 3,000 tons. But that's only under ideal conditions and in a controlled environment. In real-world lifting, especially on uneven stone blocks, their capability drops sharply. Practical engineering calculations show that modern cranes can only safely lift approximately 20–25% of the weight, significantly less than Baalbek's monoliths. The heaviest blocks of Baalbek, on 1,000 to 500 tons, are almost unliftable for modern cranes in a real-world scenario. Moreover, lifting such heavy stones isn't just challenging, but aligning them with millimeter precision is the most difficult task. Even in modern times, perfectly aligning stones weighing over 100 tons requires hydraulic jacks, laser leveling tools, and multiple synchronized cranes. The accuracy seen in the blocks at Baalbek was achieved without any modern tools, raising the question of how the ancient builders accomplished this feat. Not only lifting, but also transportation is a major puzzle. Even modern heavy transport vehicles, SPMTs, cannot maintain such capacity on uneven terrain. The path from the quarry to the temple site at Baalbek was not flat and machine-friendly. The terrain was rough, and yet the 900-ton blocks were transported to an elevated platform. Even today, considering the friction, weight distribution, and slope angle, this task would be considered extremely risky and expensive. This comparison shows that Baalbek's engineering level is not only impressive, but also seems to exceed modern limits. Now let's move on to the second most confusing and important part, the complete silence of Roman civilization. The Romans were the world's most detailed recording civilization. They documented aqueducts, roads, bridges, the Colosseum, temples, everything. Roman engineers proudly mentioned every major achievement, but not a single line in their records mentions the Trilithon blocks or the 1,500-ton stones at Baalbek. This silence poses a major question for researchers. Roman texts mention Heliopolis, the Roman name for Baalbek, and the large temples they built. But there is complete silence about the foundation stones. If the Romans had moved 900-ton or 1,000-ton stones, it would have been their greatest engineering achievement. It would have been a feat they would have proudly recounted, celebrated, and perhaps even included on their greatest construction list. But nothing of the sort is found. This blank space itself is a sign that these stones were probably already there before the Roman arrival. Experts who study Roman architecture emphasize one thing. Roman constructions always feature the Roman foot measurement. Every building, every stone block, every alignment follows the Roman unit system. But Baalbek's Trilithon blocks don't match these units. Their dimensions don't match any known Roman standard. This mismatch strongly suggests that the foundation belonged to another civilization, and the Romans simply built their temple on top. Some archaeological surveys show that the weathering pattern of the foundation stones differs from that of Roman temples. This also indicates a significant difference in the timing of their construction. Roman engineers built the upper layers of the temple complex, but left the foundation stones untouched. If they had built them, their records would surely have mentioned it. This silence in the Romans' highly organized documentation system raises a major question. Who did the work? The comparison of modern capability versus ancient capability and the Roman silence together deepen the mystery of Baalbek. Modern engineering limitations show that this task isn't just difficult, it remains highly complex even today. And the absence of Roman documentation suggests that this construction was probably not part of Roman engineering. One of Baalbek's greatest mysteries is its timeline. Archaeologists and geologists both insist that its massive foundation stones date back to the Roman period. The Romans built their grand temples at Baalbek, but the platform on which these temples stand, the very foundation, is the most puzzling part. Soil analysis and comparison of weathering patterns reveal that erosion on the foundation stones is older than the Roman structures. This means that the foundation already existed, and the Romans simply built their architecture on top of it. Furthermore, Roman construction sites always have some kind of record: construction tools, inscriptions, worker camps, or building notes. But no archaeological evidence surrounding Baalbek's massive foundation blocks proves Roman involvement. This absence leads researchers to believe that the foundation was the work of an older civilization, the identity of which remains unknown. Timeline studies also suggest that these stones may date back to the Bronze Age or even older. Another strong indication is the stone cutting pattern. Roman-style cutting has uniform chisel marks, but the cutting pattern on the largest stones at Baalbek is irregular and very deep, a mismatch that doesn't match the capability of Roman tools. This mismatch further confuses the timeline for archaeologists. If the Romans didn't cut or lift these stones, then which civilization possessed the technology to create such mega blocks? Now let's discuss the lost construction technique problem, Baalbek's greatest engineering mystery. The question is, could traditional methods like ramps, levers, or pulleys work for such heavy stones? Theoretical models suggest that ramps are possible, but in practice, ramps so steep, wide, and strong would conflict with ground stability. To slide a 1,500-ton stone down a ramp requires greatly reducing friction, but ancient lubrication or rolling methods are not considered effective for such huge stones. The use of levers and pulleys was also limited. Ancient wooden beams or ropes could never have supported the structural pressure of such a heavy weight. Even in modern tests, wooden pulleys fail at loads of 50-60 tons. The Baalbek stones were approximately 20-25 times heavier. Calculations clearly show that conventional pulley systems were practically inaccessible at the time. This is what led research to a dead end, because known ancient tools had no such capacity. Another technical issue is placement accuracy. The Trilithon blocks were not only moved, but also fitted with millimeter precision at a height of 23 feet. Moving such massive stones to such a high elevation is an impossible level challenge. Even modern engineering requires synchronized hydraulic systems, lasers, and multiple cranes to place heavy blocks with such precision. Achieving such precision in ancient times with existing tools is mathematically inaccurate. Transport is equally puzzling. The route from the quarry to the temple passes through uneven terrain. Sliding a stone weighing 1,000 plus tons on a rough surface is considered nearly impossible due to both friction and terrain. Modern simulations show that both the population and workforce size of the time were insufficient to move this weight. This mismatch proves that traditional human-only methods could not have worked on this scale. Taking both the timeline and technique together, Baalbek clearly appears to be the result of an ancient capability that was very different from Roman engineering. The Romans certainly worked here, but the foundation blocks do not match their engineering system. Techniques that seem theoretically possible practically fail on this scale. That is why researchers say that the foundation of Baalbek is an example of the engineering of an older civilization. An example that even today raises questions about both known history and known techniques. Baalbek's most complex engineering puzzle begins with transport, the route from the quarry to the temple site. The quarry is located on the same hill as the temple complex, but the distance is not easy. The terrain is uneven, with slopes, and natural ridges are also present in many places. Modern simulations show that moving stones weighing 800–1,500 tons on such terrain is extremely difficult. The lack of an even surface causes friction to increase, making it nearly impossible to slide the stones. Therefore, researchers attempt to reconstruct the path between the quarry and the temple, but until now, no clear evidence has been found of the exact route the ancient builders used. A major issue in transport was slope control. The quarry is slightly higher than the temple, but there are uneven dips and rises in between. If the stones had been slid, the weight would have caused uncontrolled acceleration, potentially damaging the entire structure. In modern engineering, moving a 100-ton object up a slope requires multiple brakes, anchors, and hydraulic controls. No trace of these controls remains at Baalbek, indicating that the transport method was not simple log rolling or manual sliding. Friction calculations also mismatch, because such heavy stones would not have moved even when placed on wooden supports. This means that the transportation technique could not have been based solely on manpower. Another challenge in path reconstruction is support platforms. Slowly moving such large stones would have required temporary ground reinforcements, but archaeologists have found no such remains between the quarry and the temple. There should have been footprints or camp remains of thousands of workers, but none have been found so far. This suggests that the transport method differed significantly from normal techniques, or that the work was undertaken at a time when the landscape and climatic conditions were different. The exact method of transport remains one of Baalbek's greatest unsolved engineering mysteries. The question now arises, why was it necessary to place such large stones? The builders of Baalbek didn't use such massive megaliths just for show. Archaeological studies show that the foundation was built as an extremely stable platform. Such heavy stones protect the foundation from long-term settlement, earthquake shocks, and soil erosion. Baalbek lies in an earthquake-prone region, so placing massive stones increases the stability of the entire structure. This may have been a practical engineering purpose. Another possibility is symbolism. Ancient civilizations often used large stones as symbols of power and permanence. The larger the stone, the greater the authority and cultural significance. Building a massive foundation at a sacred site like Baalbek may have been a way to show that this place was more important than any other temple or settlement. The use of large stones may also have indicated that the structure remained intact, unbroken, and sacred for many generations. Some researchers even believe that later civilizations, such as the Romans, built their grand temples on such a strong foundation. This means that the ancient builders created a base that could support centuries of architectural expansion. This points to a long-term engineering vision. Transport mystery and purpose. Considered together, Baalbek is not just an ancient site, but an engineered platform whose purpose was both practical and symbolic. Such massive stones appear to have been used not to meet the needs of a single generation, but to address the needs of many future civilizations. For this reason, Baalbek's foundation is still considered one of the world's strongest and most mysterious ancient constructions. The most interesting thing about Baalbek is that while Roman temples stand here, their foundations don't match Roman architecture. Archaeologists have long pointed out that the carving style, columns, and layout of the Roman temples fully follow Roman engineering, but the massive 1,500-ton stones beneath them appear to be much older. They appear to be two distinct construction phases. The upper part dates to the Roman era, while the foundation appears to be several centuries older. Roman inscriptions also mention only the temple construction, not the foundation stones. If the Romans had built these stones, they would have certainly recorded them, as this would have been their greatest engineering achievement. This contrast strongly suggests that the base was the work of an older civilization. Now let's turn to the measurement mystery. Roman architecture followed a strict measurement system called the Roman foot, approximately 29.6 centimeters. This unit is clearly visible in the planning and layout of every Roman building, but the Trilithon blocks and foundation stones from Baalbek do not exactly match this measurement. Their length, height, and width do not align with Roman units, nor do their ratios fit Roman architectural standards. This mismatch clearly suggests that the foundation stones were made using a different measurement system, one that we have not yet clearly identified. The exact scale and proportions used by the ancient builders remain a mystery. Tool marks also support this theory. Roman tools were known for sharp chisels and iron cutters, which leave fine and consistent marks on the surface. However, the marks on the largest stones from Baalbek are uneven, deep and wide, which do not match the pattern of Roman chisels. This means that either older tools were used or a method not documented in Roman engineering was used. This difference proves that the craftsmanship of the foundation stones differed from that of the Roman era, and they were made by an older group whose techniques we do not understand today. Weathering and erosion studies also point to this. The stone surfaces and foundation stones of Roman temples have different weathering patterns. Erosion on the foundation stones appears deeper and older, suggesting they were exposed to natural elements long before Roman construction. Soil layer analysis also supports this. The soil surrounding the foundation shows older occupation layers, while the upper temple layers are relatively younger. This difference makes it clear in the E-era timeline that the foundation predates the Roman arrival. Soil age comparison also reveals an interesting point. The age of organic material in the soil beneath the temple and in its immediate surroundings matches the age of the foundation stones, but the Roman debris layer is significantly younger. This suggests that the site was used by foundation builders, and then the Romans arrived later and erected their structures on the same base. Looking at the foundation stones of Baalbek, engineers still wonder how such heavy blocks were lifted. Modern experts have tested several theories, and three methods are considered the most logical. The first is the multi-layer ramp theory. It suggests that ancient builders would have built high ramps in several stages, and the stones would have been slowly slid up them. However, the biggest issue with this method is that to move stones weighing 900, 1,500 tons steadily, the ramp would have to be very wide, strong, and gently sloping, a fact practically impossible with the manpower and materials available at the time. Nevertheless, this theory is considered due to the basic structure. The second theory is the counterweight lift system. It posits that heavy stones may have been lifted with the help of ropes and counterweights. The idea is that several smaller weights could work together to lift a larger weight. This concept seems theoretically sound, but in practice, the strength of ropes, the limits of wooden structures, and friction calculations make this method almost unworkable. No ancient rope or wooden beam could withstand 1,000 plus tons of pressure. Engineers find this technically interesting, but this theory proves weak in real-world execution. The third is the stone sliding lubrication method. Some researchers believe that the stones may have been slid on lubricated surfaces, such as water, oil, mud, or animal fat, to reduce friction. This method works for smaller stones, but the friction on a 1,500-ton stone cannot be reduced enough to forcefully move it. Modern simulations show that lubrication would help a little, but not enough to move such large blocks under control over long distances. Therefore, this theory provides a partial explanation, not a complete one. Even after studying these three theories, the biggest question remains: what was the actual method? None of the theories fits perfectly. Ramp theory involves landscape constraints. Counterweight systems fail to meet structural limits. The lubrication method reduces friction slightly, but not enough to allow the 1,000-ton block to move smoothly. This suggests that the ancient builders either possessed a technique that is now lost, or they combined multiple smaller methods to create an advanced system. Now let's move on to the final unanswered questions, and this is what makes Baalbek the most mysterious. Why are the foundation stones older than the Roman era? Why are they not mentioned in Roman records? Which civilization's measurement system belong to? Why are the tool marks different from Roman tools? Where is the exact transport route from the quarry to the temple? And the biggest question, if an older civilization did this, what level of engineering capability did they possess? All of this boils down to one point: Baalbek remains incompletely understood. We can form theories, test models, and compare calculations, but what the actual truth is remains a mystery.